So first of all, well, energy storage has started to become quite a mainstream technology recently, even though batteries have been around us for hundreds of years, actually, this different kind of storage. But there are two big reasons why we have seen energy storage, especially battery-based energy storage, take off in the last few years. The first very important one is the uptake of renewable energy. This is a graph actually from 2019, as it was the first time that renewables overtook fossil fuels in the energy mix in the UK. And like in the UK, we have seen these similar graphs anywhere else in Europe and in many other countries around the world. And what the two big factors related to this are, of course, the environmental friendliness of renewable energy, but at the same time, the cost. These are technologies with marginal cost zero. So though this means that as long as the wind blows or the sun shines, the renewable energy is actually really, really cheap. However, as I've just mentioned, is when the wind blows or the sun shines. So this means that one of the drawbacks of renewable energy is the fact that it's not dispatchable. So that's one of the places where we have seen energy storage really take off, as there's a need of greater flexibility in the electricity market. The second big driver, which we have seen, or literally related to drivers, is the uptake of electric vehicles. So electric vehicles have really entered all markets around the world. Absolutely everywhere in the world, we have seen a much greater uptake of electric vehicles than we expected. And this, I will show why it has a relationship both from a supply and from a demand point of view. From a demand point of view, because we definitely see a relationship between energy storage systems and electric vehicle owners. And from a supply point of view, because this is supporting the economies of scale for battery manufacturers like ourselves, like BYD. It's the car business, the bus business, supporting the necessary investment to make home storage batteries more economical. And this first slide about this, that I was showing about this topic, is say, well, how much energy do you need to generate to be able to charge an electric vehicle? So this is a graph of some of the most common electric vehicles in the market, and how many kilowatt hours you need in order to run for 100 kilometers. So if you have already a system at home, or you have seen the ones of your clients, you'll see that it's not so uncommon, especially spring, summer, part of autumn, to generate this much even in a small solar system. However, the issue comes with timing. So this is a graph that has been generated from a survey of German drivers, and the red line is the energy consumption or electricity consumption in a home that has an electric vehicle. Red one is during the week. And as you can see, there's a big difference between during the day and in the evening. So regardless of what's the working schedule, of course, we're talking about pre-COVID times. Nowadays, I'm sure this graph is upside down. But when people do go to the office, you see there's a big rise of demand at the end of the day, when already the sun is in most cases not shining. So you already have observed that there's a need to offset the generation time during the day to the consumption time in the evening. But for those of you that are familiar with electric vehicle batteries, so you'll be aware that the size of those batteries is much bigger than most of home batteries. So we're talking about 30 kilowatt hours, 40 kilowatt hours. So probably your customers would be thinking, well, this would be a very expensive battery for me to have at home. However, the reality, once you put together the actual behavior of drivers with the energy necessary to supply that, this is another result of the same survey, which shows how many of your yearly trips are below 10 kilometers, below 20 kilometers, below 30 kilometers. And they observe that about half of everyone's trips tend to be below 30 kilometers. This means that with the smallest battery, the smallest high voltage battery that we offer, so just with 5.1 kilowatt hours, they would be able to charge the car in full in 50% of the cases. If you have a bigger driver, you have somebody that drives longer, or that just wants to make sure that the car is almost full every time, with just 10 kilowatt hours of battery, that will cover about 80% of the potential trips. And in the extreme case of someone that wants to make sure absolutely that the car is always full at the end of the day, with just 16.6 kilowatt hours, that will cover 90% of all the potential trips. So we have seen why two forces that are unstoppable right now, renewables and electric vehicles, are actually encouraging or pushing the energy storage market here and in the future, and now in the future, sorry. But how do we go from the idea from yes, I know I need a battery, to how do I translate that into the actual needs of the customer? Well, the first thing to take into consideration is what makes people buy or not buy energy storage systems. So one thing that it's possibly quite surprising is, especially when we look at new markets, like it's the case of Belgium, the thought is, okay, well, their return of investment is what everyone is going to be thinking about. So we need to do very detailed numbers and go with those numbers to customers. But the reality is that, like many things for consumers, these are mostly emotional purchases. So of course it helps that there's a much bigger commercial incentive or economic incentive nowadays that there was a while ago. It also helps that costs are much lower now than they were just a few years ago. But the reality is, in order to get them across the line, the things that really matter to them are things such as the fact that they can protect themselves and against volatile or growing energy prices, the fact that they have that self-independence. So one of the strongest feelings with energy storage and renewable energy owners is that they can generate and use their own electricity, and that is highly rewarding. The other top cost, and we have actually seen that growing from the early buyers in 2013, 16 to the later ones, 2017, and these I'm sure these values is way higher right now, is the fact that they can contribute to the energy transition. The fact that in a very simple way and very visual way, they know how much CO2 they are saving, how much they are contributing to that cleaning of the electricity network. And the other big drivers that we have seen in the early stage, especially, but this is going down, is the technological interest, is all the early adopters, all the people that have an engineering or a curiosity on the product. There's some other drivers, but really the two big ones are these independent and the possibility of contributing to the energy transition. Okay, so let's say our customer has already decided to purchase a system. There are three main types of energy storage. They will be on-grid ones, they'll be on-grid and backup, and they'll be off-grid ones. And the three of them have their own separate considerations. The first one to take into to consider the biggest share of the market, it will be on-grid systems, especially now that the change in Belgium is related to that metering, to that connection with the grid. Of course, the big change is going to be on the on-grid systems. So the main concept to have in here is that you need to maximize equipment utilization. Maximizing equipment utilization means that you need to I would recommend designing the battery to be as close as possible to be in use all year long to the maximum. Of course, if you design a battery to be fully utilized in winter, it would be massively oversized for undersized for summer, and vice versa. If you design a battery to be only used to the 100% in summer, it will be half used in winter. So based on these, these are some graphs from HW Berlin that show the level of self-consumption, so how much of your own generated power you would be using internally, comparing the size of an energy storage system with the size of your PV system. So, and it is a division between the storage capacity divided by the number of the kilowatt hours, megawatt hours that home of that business would be consuming over the year. And you see that as you go larger on the solar system, the PV system that you have on top, you'll have to go higher on the size of the battery to be able to achieve a high level of energy in the of self-consumption rate. And on the other side, we're talking about grid independence. So how much of the electricity that this home or business consumes is coming from their own renewable energy. Realistically, this is the one on the right is the one that you really need to realize that a grid independency of greater than 80%, it's going to be a very, very, very high investment. So in general, what we will always recommend is try to achieve a yearly grid independence of about 60 to 70%, and that is going to give you a fairly good return on investment. And once you have the data, once you have observed really in every season of the year how much electricity the customer is exporting, you can decide to add more batteries. This is a possibility that we offer with the Battery-Box. So then you can expand at any time, 1 year, 2 years later, when you already have the data and the customer has already seen the system working and is excited about the idea of adding more batteries to it. The second point to take into consideration is the backup. So the backup, one of the things it starts to make you think is not only about nominal power, but also about the different power surges, the different increases in power during the day, depending on the type of loads that you have connected. Because once the system is in backup, the battery needs to power everything. So not only the battery and the inverter, but actually all the loads. So you have different ways of managing this. Some inverters will give you the option of powering the whole load, so the whole house with their backup system. Some others will let you have a separate backup loop, and some of them will even have a much lower power backup option where you can just whenever there's a power cut, you can just connect whatever you want to that specific backup loop. So it tends to be in many cases a low power connection. So we understand that for consumers it's very difficult to change their behavior, but they need to understand that if they were to design their energy storage system to power all the heaviest users in the house, they actually probably will have to oversize quite significantly their system. So they need to be aware of these graphs such as this that shows that the temporary consumption of some of their appliances. So they decide if they want to have an energy storage system to power, they just make the critical loads go, or they want to have a much larger system that powers also the big appliances. And this is related to backup and also especially to off-grid systems, you need to take into consideration the type of loads, because it's not only about the power you can see, it's also the electricity surges that you don't see. This is the reason why we offer a document called the minimum configuration list, or a compatibility list between inverters and batteries, because this table will help you understand for the size of an inverter you've chosen, the maximum power surge that the inverter allows, how many batteries you need to be able to support that. If you have a very good knowledge of the type of loads that you have connected, if you have a very good knowledge of when they're going to be used, potentially you can try to size the battery exactly to that. But this configuration list allows you to power any potential power surge that that size of an inverter will be able to supply.